Alright, let's get started with 6.6, logarithmic and exponential equations. So we'll continue on a little bit what we did in 6.5 here, solving for x. So objective 1, let's solve when the equations are logarithmic. So just a reminder here that if you have a problem where you have a log, you can always rewrite it so it's exponential. Remember that y here becomes the power, the y right there. There we go. Okay, and then again, if you can get the same base on either side, you can cross them off so that m equals n. Alright, so one other small thing here, remember that your base has to be positive here on all of these for these to work. Alright, so let's jump in here. So log 3 of 4 equals 2 log 3 of x. These are almost ready to cancel, but we need to bring this 2 up here. So we'll end up with log base 3 of 4 equals log base 3 of x squared. And so now cancel out those log 3's and 4 equals x squared. We'll square root both sides and we'll have a plus or minus 2 equals x. But remember that for all logarithm problems you have to have the positive there because remember the parent function looks like this. X has got to be greater than 0. So you can't have the negative part. X equals 2 is your answer. Try problem 13. Alright, next one up. Log base 2 of x plus 2 plus log base 2 of 1 minus x equals 1. Let's go ahead and condense these into log 2 of x plus 2, 1 minus x equals 1. And then let's go ahead and rewrite this. So this will be 2 to the first equals x plus 2, 1 minus x. So remember, base 2 to the first is how we end up with this over here. And so now let's expand this. This is foiling x minus x squared plus 2 minus 2x. And so let's go ahead and put all this together. So we've got 2 equals negative x squared, and we've got an x minus a 2x, that's going to be minus an x, and then plus 2 here. And let's bring everything over so that the negative x squared becomes positive. So x squared, where did the plus 4 come from? Plus 2, sorry. Just getting ahead of myself because this will be, when we minus here, we'll end up with a 0. Those will cancel out. And so we'll have x squared plus x equals 0. And so let's factor out x plus 1 equals 0. And so we have here x equals 0 or negative 1. Now you don't automatically get rid of the negative 1. You have to check on this up here because this in here and this in here need to be positive. So 0 plus 2, that works. 1 minus 0, okay, that works. So 0 is good. Let's check negative 1. What's negative 1 plus 2? That's a positive. What's 1 minus negative 1? That's also a positive. So these are both going to work. Alright, so go ahead and use that information and try problem 21. Okay, let's try this situation here. Combine them. Natural log of x minus 1 times x equals natural log of x plus 2. We're ready to go to cancel these natural logs, and so we've got x squared minus x equals x plus 2. And let's get 0 on one side, so x squared minus 2x minus 2 equals 0. And at this point, we're going to need to use the quadratic equation. So we'll have 2 plus or minus the square root of 4 minus 4ac all over 2a. That'll turn into a 2 plus or minus square root of 4 plus 8, which is 12. So let's pull out a 4 here and get 2 plus or minus. Square root of 4 is 2. Root 3 all over 2. And so we end up with 1 plus or minus root 3. We have to check to make sure both of those will work. If we go 1 minus root 3, we've got a negative. And if we go a negative minus a negative, we get a negative in here. Can't have negatives in the parentheses. So our answer here is going to be 1 plus root 3, and that will work here. 1 plus root 3 is bigger than 1, so it'll work here, and 1 plus root 3 plus 2 is still positive. Works there as well. Try problem 31. Alright, let's go the other direction. We've solved logarithmic problems. Now let's solve exponential equations. So, just a reminder, if you can get your bases the same, you can cancel them and get u equal to v. Remember that a, again, has to be bigger than 0. 3 to the x equals 7. Okay, in this problem, what we can do is put a log on both sides. So 3 to the x equals 7. Let's go ahead and put a log, and just rewrite, I'm sorry, let's rewrite this. Log base 3 of 7 equals x. We've got x all by itself. Just rewriting this, if we have a variable in the exponent, we want to use a log to solve it. Alright, so you can plug that straight into your calculator, round to 2 decimal places, 1.77 is what you get for x. Try problem 35. Alright, so what if we have something like this where we're not quite ready to take the logarithm? Let's divide by 5 first, and now we'll have 2 to the x equals 3/5. So now we're ready to do a log. Log base 2 of 3/5 equals x, and that can go straight into your calculator. X equals negative 0.74. Alright, and let's go ahead and, I think I skipped one, there we go. Try one where we have x's on both sides of the problem. So what we're going to do here is, we're going to have to use a log, but that's only going to get rid of one side. So in this situation, I'm going to pick the more complicated looking one. So the 2x plus 3, since it's a 2x, slightly more complicated on this side, it really doesn't matter. We're going to pick one base for our log. So in this case, I'm going to choose log base 5 from here. Could use log base 2 as well. Of 2x minus 1 equals log base 5 of 5, 2x plus 3. On the right side, it cancels out, and we're left with 2x plus 3. On the left, this x minus 1 will go out in front, and so we'll have x minus 1 times log base 5 of 2. So we can take that log base 5 of 2 and put it in our calculator, and it turns into 0.43. So now we have 0.43x minus 0.43 equals 2x plus 3. Let's bring things to the same side. We're going to subtract 0.43x and end up with 1.57x. Let's minus 3 to the other side and get negative 3.43. Divide both sides by 1.57 and you end up with x is equal to negative 2.19. Alright, so the key here is pick one of the bases and use that as a log to get started. Alright, let's try problem 41. Okay, this one's a little tricky. We'll definitely go over something like this in class, but watch me walk through it first. So the key here is to get the same base between 9 and 3. So we can do that by saying 3 squared to the x minus 3 to the x minus 6 equals 0. Now, here's the trick. 3 squared to the x is equal to 3 times 2x, which you could rewrite as 3 to the x squared. Alright? Those rules of exponents are allowed. So now, this is, if we just rewrite it as 3 to the x squared minus 3 to the x minus 6. If we use a placeholder, we'll use u. U is 3 to the x. So everywhere I see a 3 to the x, I'm going to write down a u. So this is u squared minus u minus 6 equals 0 still. Let's go ahead and factor this. This is u minus 3 and u plus 2 equals 0. So u equals either 3 or negative 2. So let's go back and see what u actually equals. 3 to the x equals 3, or 3 to the x equals negative 2. Remember that we have to have a positive here, so this one's out of here. This is 3 to the first, so x equals 1. Alright, complicated problem. Use that property of substitution to help you here. Try problem 53. Alright, last objective. Let's solve logarithmic and or exponential equations using a graphing utility. Alright, so if we have a problem like this, and we want to solve it using a graphing utility, we can go grab our graphing calculator and plug both of these in. So I've already done that. 2x minus e to the 2x, the left side is y1, 4 is y2. Go ahead and graph it, and see where they cross. Now you can see in this one, they don't cross anywhere, so the answer to this is no solution. If they did cross, you would want to calculate, so second trace, you would want to calculate the intersect, which is number 5. Alright, and it'll ask you for the first curve. You can see there the cursor's on there, so I just hit enter anywhere. I'll hit enter anywhere here, and since it's a guess, there's nowhere for me to say they cross, so but you would want to hit enter where they cross, and this will give me an error because they don't cross each other. So there you go, no solution. Alright, so use that as a jumping off point for 63. Any questions? Make sure we're asking them in class, and good luck.